How Caterpillar giant excavators are manufactured inside the heavy machinery plant. Full process. Intro. What does it take to build one of the most powerful machines on Earth? A machine capable of moving thousands of tons of earth, digging deep foundations, loading massive trucks, and operating day and night in some of the harshest environments imaginable. Today, we are going deep inside a modern heavy machinery manufacturing plant to witness the incredible process of building Caterpillar giant excavators. From raw steel and massive castings to powerful diesel engines, hydraulic systems, robotic welding stations, and rigorous testing procedures, every excavator goes through an extraordinary manufacturing journey before reaching mines, construction sites, and infrastructure projects around the world. These machines are engineering giants. Some weigh hundreds of tons. Some stand taller than a two-story building. And some can move enough material in a single bucket load to fill an entire pickup truck. But before they begin shaping landscapes and powering major construction projects, they must first be built inside one of the most advanced heavy equipment factories in the world. Inside the plant, gigantic cranes move steel structures weighing several tons. Robotic welding systems generate showers of sparks. Engineers inspect components with incredible precision. And slowly, another giant excavator begins to take shape. So sit back, relax, and let's go inside the heavy machinery plant to discover the full process of how Caterpillar giant excavators are manufactured. Section 1. Designing a giant excavator. Long before manufacturing begins, years of engineering and research take place behind the scenes. Designing a giant excavator is far more complex than many people realize. Engineers must create a machine that is powerful, reliable, fuel-efficient, safe, and capable of operating continuously under extreme conditions. Excavators work in mines, quarries, road projects, ports, and major construction sites. Many operate 24 hours a day for years at a time. That means every component must be designed for durability. Using advanced computer-aided design software, engineers create digital models of the entire machine. They simulate stress, vibration, hydraulic pressure, structural loads, and operating conditions. Every weld, every hydraulic cylinder, every steel plate, and every mechanical component is analyzed carefully. Engineers also study fuel efficiency, operator comfort, visibility, maintenance access, and environmental performance. Modern excavators contain sophisticated electronic systems that monitor performance and help improve productivity. After years of testing and refinement, the final design is approved. Now the manufacturing process can begin. And it all starts with steel. Section 2. Steel preparation and fabrication. The backbone of every giant excavator is steel. Large shipments of high-strength steel arrive at the factory every day. These materials will eventually become the excavator's frame, boom, stick, bucket, and structural components. Inside the fabrication area, enormous steel plates are unloaded and moved by overhead cranes. Some plates are several centimeters thick and weigh many tons. Computer-controlled cutting machines begin shaping the steel. Advanced plasma cutters and laser systems slice through metal with incredible accuracy. Every component must meet exact specifications. Even a small error could affect structural strength or assembly quality later. After cutting, the steel moves to forming stations. Large hydraulic presses bend and shape components into the required forms. Some pieces become frame sections. Others become boom structures, bucket components, or reinforcement plates. Once the steel parts are prepared, they move to one of the most exciting areas of the factory. The welding shop. Section 3. Massive welding operations. Inside the welding area, sparks fly constantly. This is where the giant excavator begins to take shape. Large steel sections are positioned carefully in assembly fixtures. Robotic welding systems and skilled welders work together to join the components. The structural frame is assembled first. This heavy-duty structure supports the engine, hydraulic systems, operator cabin, and working equipment. Because excavators experience tremendous forces during operation, weld quality is absolutely critical. Every weld must withstand years of vibration, stress, and heavy workloads. Advanced robotic welders perform many of the repetitive tasks. These machines deliver consistent, precise welds across large structures. At the same time, highly skilled human welders handle complex joints and specialized assembly work. Large boom sections are assembled separately. The boom is the excavator's primary lifting arm. It must be incredibly strong while remaining as lightweight as possible. The stick and bucket linkage structures are also welded carefully. Once welding is complete, inspectors use ultrasonic testing, magnetic particle inspection, and other advanced techniques to verify weld quality. Only components meeting strict standards move forward. Section 4: Machining critical components. While structural fabrication continues, other factory areas focus on precision machining. Excavators contain thousands of moving parts that require extremely accurate manufacturing. Large machining centers shape critical components such as bearing housings, pivot joints, drive assemblies, and hydraulic mounting points. Computer-controlled CNC machines perform these tasks with incredible precision. Some components must meet tolerances measured in fractions of a millimeter. Massive rotary tables allow heavy parts to be machined from multiple angles. Engineers constantly monitor production quality. Any deviation from specifications could affect machine performance or reliability. Once machining is complete, the parts are cleaned, inspected, and prepared for assembly. Section 5: Building the powerful diesel engine. At the heart of every giant excavator is a powerful diesel engine. These engines generate the enormous power needed to operate hydraulic systems and move massive loads. Engine production begins with large cast iron engine blocks. These blocks undergo extensive machining before assembly begins. Workers carefully install crankshafts, pistons, connecting rods, camshafts, fuel systems, and turbochargers. Modern excavator engines are highly sophisticated. They must deliver maximum power while meeting strict emissions regulations. Advanced fuel injection systems improve efficiency and reduce environmental impact. Electronic engine management systems constantly monitor performance. After assembly, every engine undergoes rigorous testing. Engineers check oil pressure, fuel consumption, cooling performance, emissions, and power output. Only engines that pass every inspection continue toward final assembly. These engines are built to operate for thousands of hours under extreme workloads. Reliability is absolutely essential. Section 6: Hydraulic System Manufacturing. Hydraulics are what make excavators truly powerful. The hydraulic system converts engine power into the force needed for digging, lifting, and moving heavy materials. Inside the hydraulic assembly area, workers build pumps, valves, cylinders, and control systems. Hydraulic cylinders are especially important. These massive components provide the force that moves the boom, stick, and bucket. Each cylinder is manufactured with exceptional precision. The seals must withstand extremely high pressures. Even small leaks could reduce performance significantly. Hydraulic pumps are assembled and tested carefully. These pumps generate the flow and pressure needed to power the machine. Advanced control valves regulate hydraulic movement precisely. Modern excavators use sophisticated electronic control systems to optimize hydraulic efficiency. This helps improve productivity while reducing fuel consumption. Before installation, every hydraulic component undergoes pressure testing. Only fully approved systems move to final assembly. Section 7: Undercarriage Assembly. The undercarriage forms the foundation of the excavator. It supports the entire machine while providing mobility and stability. Inside the assembly area, workers begin building the track system. Heavy-duty track frames are assembled first. Rollers, idlers, and drive sprockets are installed carefully. The tracks themselves are made from extremely durable steel components. These tracks must survive constant contact with rocks, dirt, mud, and abrasive materials. Large mining excavators may use track systems weighing many tons. Each component is engineered for maximum durability. The swing bearing is installed next. This critical component allows the upper structure to rotate smoothly. Some swing bearings are several meters in diameter. They must support enormous loads while operating reliably for years. Once completed, the undercarriage moves toward final assembly. Section 8: The Main Assembly Line. Now comes one of the most exciting stages of production. Final assembly. This is where all the major components come together. The undercarriage is positioned on the assembly line. Large cranes lower the upper structure onto the swing bearing. The fit must be perfect. Engineers connect the engine, hydraulic systems, fuel tanks, cooling systems, and electrical systems. Massive hydraulic hoses are routed throughout the machine. Electrical wiring harnesses connect sensors, displays, and control systems. The boom is installed next. This operation requires enormous cranes because the boom sections can weigh several tons. The stick follows. Then the bucket linkage and bucket itself. Slowly, the excavator begins to resemble the giant machine seen on construction sites. Each installation step requires precision and coordination. Safety is critical throughout the process. Workers follow strict procedures while handling these enormous components. Section 9 Operator Cab Installation. Modern excavators are designed not only for performance but also for operator comfort. The cab is essentially the command center of the machine. Inside the cab assembly area, technicians install seats, controls, displays, and safety systems. Modern excavator cabs often include air conditioning, heating, suspension seats, touchscreen displays, and advanced monitoring systems. Visibility is extremely important. Large windows provide excellent views of the work area. Noise insulation helps reduce operator fatigue during long shifts. Electronic joysticks allow precise control of hydraulic functions. Computer systems display machine diagnostics, fuel consumption, maintenance information, and operating data. Once completed, the cab is lifted carefully into position and secured to the excavator. Section 10 Electronics and Smart Technology. Modern excavators contain sophisticated electronic systems. Sensors monitor hydraulic pressure, engine performance, fuel usage, temperatures, and machine health. Technicians install wiring systems throughout the machine. Control modules are connected and programmed. GPS systems may also be integrated for fleet management and job site monitoring. Some advanced excavators include semi-autonomous features that improve digging accuracy and productivity. Remote diagnostics allow technicians to monitor machine performance from anywhere. These technologies help reduce downtime and improve efficiency. After installation, engineers verify that all electronic systems communicate correctly. Section 11 Painting and Finishing. Before testing begins, the excavator receives its final appearance. Large components undergo cleaning and preparation. Protective coatings are applied to prevent corrosion. The machine then enters the paint process. Specialized industrial paints protect the excavator from harsh environments. Mining and construction equipment often operates in extreme weather conditions. The paint must withstand sunlight, moisture, chemicals, and abrasion. Multiple layers are applied carefully. After curing, the machine receives decals, safety markings, and branding. The familiar caterpillar appearance begins to emerge. Now the machine is nearly complete. But it still must prove itself through rigorous testing. Section 12 Quality Control and Inspection. Every giant excavator undergoes extensive quality inspections. Engineers examine structural components, hydraulic systems, electronics, and assembly quality. Laser measurement systems verify alignment. Hydraulic circuits are inspected carefully. Electrical systems undergo comprehensive testing. Any issue is corrected immediately. Quality control is one of the most important stages of production. Customers depend on these machines for critical projects. Reliability is essential. The inspection process ensures every excavator meets strict manufacturing standards. Section 13 Functional Testing. Now comes the moment of truth. The excavator is started for the first time. Engineers monitor diagnostic systems closely. The engine comes to life. Hydraulic systems are activated. Operators begin testing machine functions. The boom rises. The stick extends. The bucket moves. The upper structure rotates. Every movement is analyzed carefully. Hydraulic pressures are measured. Engine performance is evaluated. Control systems are tested under various operating conditions. Some machines undergo simulated work cycles to verify performance. The goal is to ensure the excavator performs exactly as designed. Section 14 Final Testing and Delivery. Before leaving the factory, the excavator undergoes final testing. Professional operators drive and operate the machine in controlled environments. Digging performance is evaluated. Travel systems are tested. Braking systems are inspected. Noise and vibration levels are measured. Engineers collect detailed data throughout the process. Only machines meeting all performance standards receive final approval. Once approved, the excavator enters the finishing area. Protective covers are installed. Documentation is prepared. Shipping arrangements are finalized. Some excavators are transported by truck. Others travel by rail or shipped to destinations around the world. Watching a completed giant excavator leave the factory is an impressive sight. It represents thousands of hours of engineering, manufacturing, assembly, and testing. Outro. From raw steel and massive welding operations to powerful diesel engines, advanced hydraulics, and rigorous testing, the production of Caterpillar giant excavators is one of the most impressive manufacturing processes in the world. These machines play a vital role in building roads, bridges, mines, ports, cities, and major infrastructure projects across the globe. They are a perfect combination of engineering excellence, industrial power, and modern manufacturing technology. And now, whenever you see a giant excavator working on a construction site or mining operation, you will understand the incredible journey it went through before beginning its first day of work. Thanks for watching this complete inside look at how Caterpillar giant excavators are manufactured inside the heavy machinery plant. If you enjoyed this video, make sure to like, subscribe, and turn on notifications for more amazing factory and engineering documentaries from around the world. How Caterpillar giant excavators are manufactured inside the heavy machinery plant full process. Intro. What does it take to build one of the most powerful machines on Earth? A machine capable of moving thousands of tons of earth, digging deep foundations, loading massive trucks, and operating day and night in some of the harshest environments imaginable. Today, we are going deep inside a modern heavy machinery manufacturing plant to witness the incredible process of building Caterpillar giant excavators. From raw steel and massive castings to powerful diesel engines, hydraulic systems, robotic welding stations, and rigorous testing procedures, every excavator goes through an extraordinary manufacturing journey before reaching mines, construction sites, and infrastructure projects around the world. These machines are engineering giants. Some weigh hundreds of tons. Some stand taller than a two-story building. And some can move enough material in a single bucket load to fill an entire pickup truck. But before they begin shaping landscapes and powering major construction projects, they must first be built inside one of the most advanced heavy equipment factories in the world. Inside the plant, gigantic cranes move steel structures weighing several tons. Robotic welding systems generate showers of sparks. Engineers inspect components with incredible precision. And slowly, another giant excavator begins to take shape. So sit back, relax, and let's go inside the heavy machinery plant to discover the full process of how Caterpillar giant excavators are manufactured. Section 1. Designing a giant excavator. Long before manufacturing begins, years of engineering and research take place behind the scenes. Designing a giant excavator is far more complex than many people realize. Engineers must create a machine that is powerful, reliable, fuel-efficient, safe, and capable of operating continuously under extreme conditions. Excavators work in mines, quarries, road projects, ports, and major construction sites. Many operate 24 hours a day for years at a time. That means every component must be designed for durability. Using advanced computer-aided design software, engineers create digital models of the entire machine. They simulate stress, vibration, hydraulic pressure, structural loads, and operating conditions. Every weld, every hydraulic cylinder, every steel plate,